Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul Hakim Rosli. Number metric 1223260. And today I will present to you about econometric assignment, the impact of education, experience, tenure, and gender on average hourly earnings across sectional analysis. Now we will go to introduction. Wage inequality remains a persistent issue in global labor market. Factors such as education, experience, tenure, and gender have long been identified as critical determinants of earnings. Understanding this relationship is essential for developing effective policies to reduce income inequality and promote fair labor practice. This study focuses on exploring the causal effect of education, experience, tenure, and gender on average hourly earnings. Next, research problem. Despite numerous studies on wage determinants, disparity in earnings due to gender and differences in educational and professional background remain significant. This study aims to investigate how education, work experience, job tenure, and gender influence average hourly earnings across different sectors and regions. The findings will provide insight into addressing wage disparities and enhancing labor market equity. Literature review. First, education and earning. Baker 1993 emphasized that higher education level improve skill and productivity, leading to increased earning. Numerous studies support the positive correlation between education and wages. Second, experience and wage growth. Research 1974 discussed how accumulated work experience enhance skill over time, resulting in higher wages. Empirical evidence shows strong relationship between work experience and increased earnings. Then, tenure and job security. Hashimoto 1981 suggests that job tenure represents loyalty and accumulation of firm-specific skill, which often lead to higher wages. Employees with longer tenure typically receive rewards for their commitment and accumulated expertise. Fourth, gender wage gap. Blow and Kahn 2017 analyzed the persistent gender wage gap, attributing it to factors like occupational choice, work experience, and potential discrimination. Closing this gap requires addressing structural and cultural barriers. Fifth, combined effect of education, experience, and gender. Card 1999 explore how education and experience generally increase earnings, but gender disparity can diminish these gains. Promoting gender equality in education and employment is essential for reducing wage gaps. 6. Policy intervention and wage inequality. Freeman 2002 discussed the impact of policy intervention such as a minimum wage laws and affirmative action on reducing wage inequality. For example, in the United States, the introduction of Fair Labor Standards Act led to significant reduction in wage disparity by setting minimum wage threshold. Now we will move to data description and methodology. For data description, dependent variable, average hourly earnings, the average hourly wage earned by individuals. And for independent variable, we have 4. First, education level. We have years of formal education complete, experience, number of years with current employer, tenure, number of years with current employer too, and female we divide by 2 categories. Male for gender, male and female we count as 1. Now we will go for methodology. First is model specification. The study employ multiple linear regression (MLR) to analyze the impact of independent variable on average hourly earnings. The regression model is specified as follows, which equal to beta naught plus beta 1 multiplied by loop plus beta 2 multiplied by expert plus beta 3 multiplied by tenure plus beta 4 multiplied by female plus C. Where wage is wage of individual, beta naught is intercept, and beta 1, 2, 3, 4 is coefficient for independent variable. C is error term capturing unobserved factor affecting wage. Second, hypothesis testing. For each independent variable, the null and alternative hypotheses are defined as H0, the variable has no effect on weight, and H1, the variable significantly affect weight. The significance of coefficient is assessed using t-test, and the overall model significance is evaluated using f-test. Uh, for goodness of it, the model is measured using R square, the proportion of variance in weight explained by independent variable, adjust R square, adjust for number predictors to account for overfitting, and interpretation of coefficient. The estimate coefficient are interpreted as change in dependent variable which associate with 1 unit change in corresponding independent variable, holding all other variable constant. For binary variable female, the coefficient measure the difference in wages between females and male. And the last one is diagnostic test. To ensure the validity of model, diagnostic tests is conducted as multicollinearity assessed using variance inflation factor VIF, uh, homoscedasticity check using residual plot and statistical test, normality of residual evaluate through visual inspection or test like Chevrolet test. Now we will move to the result. For question 1, descriptive analysis, measure of central tendency. For mean, the average education is 12.38 years, indicating that most individuals have complete high school or have some college education. The average hour experience is 18.43 years, suggesting that seasoned workforce. The mean of binary gender variable female is 0.48, implying the nearly even distribution of male and female. The average hourly wage is 5.93, showing a moderate income level. The average tenure is 4.95 years, suggesting that moderate job stability among the sample. And for median, the median education is 12 years, aligning with the mean, indicating symmetric distribution. The median experience is 15 years, lower than mean, suggesting that right skewed distribution. The median of female is 0, showing a slight majority of males in the sample. The median wage is 4.5, which is lower than the mean, indicating some high income outlier. The median tenure is 1 year, significantly lower than the mean, indicating a highly skewed distribution. And for measure of variation, standard deviation, education 2.29 and experience 13.83 show significant variation, with experience exhibiting a much broader range value. Wage 3.81 and tenure 7.9 shows substantial variability, with tenure having the highest dispersion, reflecting significant difference in job stability across individuals. For range from 4 to 18 years show widespread of educational attainment. Experience range from 1 to 48 years, indicating some highly experienced individual, and wage range from 2.14 to 22.86, reflecting a broad range in earning. Tenure range from 0 to 39 years, highlighting a large difference in job tenure across the sample. For measure of shape, skewness, adult negative 0.36 and female 0.08 show a near symmetrical distribution. Experience 0.53, wage 2.16 and tenure 2.23 are positively skewed, indicating a more individual have lower value in this variable. For courtesies, wage 8.82 and tenure 7.92 have high courtesies, indicating a heavy tail distribution with potential outlier. For adult, 5.03 also show some degree of weakness, suggesting some deviation from normality. So, this interpret as central tendency, the mean and median edu explain the typical level of education and experience. However, the mean median difference in wage and tenure suggests skewed distribution and potential income inequality of varied job. For variation, the large standard deviation in experience, wage and tenure point to diverse experience, earnings and job tenure among individuals. This variability might be due to a difference in industry, region, or individual circumstance. Shapes the positive skewness and hypothesis in wage and tenure suggests a small number of individuals with very high wage and long tenures, potentially skewing the overall data distribution. This finding suggests that while most individuals in the sample have moderate education and experience level, there are a significant disparity in wages and tenure. The presence of high categories and skewness in key variables underscore the importance of considering this factor in further analysis and policy discussion. We will move to the question 2. For question 2, correlation matrix. Edu and wage. The correlation is 0.358. Moderate correlation shows that education positively influences wage, but it is not the sole determinant. For edu and tenure, the correlation is 0.118. Positive correlation. A weak positive relationship suggests that higher education is slightly associated with higher job tenure, but the effect is not strong. And for the correlation between expert and tenure is 0.436. Moderate correlation indicates that as experience increase, tenure also tends to increase, reflecting career stability over time. And expert and wage correlation is 0.10999. Positive correlation. A weak positive relationship indicates that more experience is slightly associated with higher wages, but this is not a strong determining factor. For female and wage, negative 0.448. Negative correlation highlights gender wage gap, with female earning less on average than males. For female and tenure correlation, negative 0.294. Negative correlation. Weak negative relationship between female and tenure suggests that females tend to have a shorter tenure compared to males. For question 3, we move to the multicollinearity experience with BIF of 1.294. This suggests that the variance of regression coefficient for experience is inflated by approximately 29.4% due to the correlation with the other independent variable. However, this level of inflation is minimal and unlikely to pose a serious threat to the model's reliability. For education, the BIF for education is 1.058, indicating a very low level of variance inflation around 5.8%. This suggests that education is almost independent of the other variable, making it a robust predictor with minimal multicollinearity concerns. For tenure, it has the higher BIF among the variables at the 1.346. Although this is the largest BIF in this analysis, it is still well below the commonly used threshold of 5 or 10. This indicates that while there is some degree of correlation between tenure and the other independent variable, it is not severe enough to significantly impact the model's performance or the interpretability of regression coefficient. And the last one is female with BIF of 1.107. The variable female also show minimal inflation, approximately 10.7%. This implies that female does not exhibit strong multicollinearity with the other independent variables and is a stable factor in the model. And you can see the graph for VIF and R square next to the explanation. For question 4, multiple linear regression MLR model. Regression equation as before. So we just substitute the value, and for interpretation of coefficient, adduct for each additional year of education, wages increase by 0.5109 unit, highlighting the education strong impact on earning. And for as per, the negligible coefficient is negative 0.0010, and high p-value suggests experience does not significantly impact wages in this model. For tenure, each additional year of tenure increase wages by 0.0829 unit, suggesting moderate by positive return on job stability. Being female is associated with wage decrease of 2.8262 unit, a substantial and statistically significant effect, indicating a gender disparity. Question 5. This is the estimate variance of slope coefficient and the residual variance. The variance of slope coefficient, we use views to calculate using the data given. For the question C, residual variance impact, the impact residual of variance on the slope coefficient. Direct relationship, the residual variance sigma square directly affect the estimated variance of the slope coefficient. A higher residual variance increase the variance of slope coefficient, which imply greater uncertainty in the estimate coefficient. Confidence interval, the residual variance impact the width of confidence interval for the slope coefficient. A larger residual variance result in wider confidence interval, indicating less certainty about the true value of the coefficient. And for the precision of estimate, lower residual variance result in lower variance of the slope coefficient, making the estimate more precise. Conversely, the higher residual variance reduce the precision of the estimates, making them less reliable. For the statistic significant, the higher residual variance can lead to a larger standard error for the slope coefficient, potentially making it more difficult to detect statistically significant relationship between the independent variable and the dependent variable. Question 7. Hypothesis testing. Statistical significant at 0.006, indicating the education has strong positive effect on wages as per, not significant because p-value is 0.9701, suggesting experience and does not contribute meaningfully to the wage model in this context. Tenure, marginally significant, 0.0803, indicating a weak but positive relationship with wages. Female, highly significant, p-value is 0.001, confirming the gender wage gap negative impact on the female wages. Question number 8, confidence interval for adult shows a consistently positive impact, confirming its significance, and as per span 0, aligning with its non-significant, and tenure includes 0, suggesting its marginal significant. For female, it confirms a significant negative impact on the wages. For question number 9, adjusted R squared 0.3027 reflect that about 30.27% of the variation in the wages is explained by the model considering the number of predictors. This suggests a moderate fit, indicating a room for additional factors to better explain wage variability. And for question 10, impact of dropping variable. For this scenario, we dropping the expert variable, omit variable bias and expect change. Omit variable bias as mentioned, omit a variable correlation with both dependent variable which and other dependent variable can introduce bias. In this case, if Esper is correlated with Edu, female or tenure, dropping it can distort the coefficient of these remaining predictors.